Alright, in this video for the drivetrain gearbox, we'll be making the second plate that's missing over here from our gearbox, right? So let's get started with that. So obviously we want the second plate to have the same dimensions between these four holes, these two bearing holes, and all of that. So we could open up the sketch for this plate, copy it, and make a second part. That would work. The only problem with that is if I were to go back and change something on this plate, if I decided to go with bigger gears or smaller gears or something else, what would end up happening is my second plate wouldn't change, and I would have to go on the second plate as well and change those dimensions. So instead what we can do is use what's called derived parts, so that my second plate depends on this first one, and anytime I change anything about this first plate, the second one will also update. So to do that, we'll go and start a new part, and again, my setup is so that it automatically starts a new sketch, but we don't need to do that. We'll go under manage, load, and if you see here, there's this button called derive. So we'll click that and it'll open up a dialog box. We want to click on the first plate, right? So this is our first plate, that one. Hit open and it'll open this settings box, and we want to select this orange flat sort of symbol over here. What this basically means is it's similar to construction. It creates like a surface, and basically it won't interfere with our extrusion or anything like that, and it won't think there's like two different parts over here. So we'll do that. And what deriving parts basically does is it creates a link between this first plate and our second and our whatever else we do on this file. And so what we can do now is we can do start sketch on this XY plane, and here what we can do is use project geometry. And what project geometry does, if you don't know, is basically if there's any holes or circles or edges anywhere, you can make that a part of your sketch. So we'll select the we don't need these motor holes, right? Because the motor already, if you look here, the motor holes are done, they're ended here. We don't need anything here for them. So all we need to do project geometry for is these two bearing holes and our four holes that hold the gearbox together, right? We have that, and if you look on a completed gearbox, right, we have the two bearing holes and these four holes for the standoffs that are here, right? Now you'll see that there's actually four additional holes, and what these holes are responsible for is attaching this whole gearbox to the drivetrain. So let me open up our drivetrain for last year, and if you look, we'll have to skip that. So let it open. Okay, so if you look, let's get rid of the bumpers. You'll see here that the gearbox is attached to this 2x1. So that's my gearbox, that's the 2x1. It's attached, and it's attached using these four screws over here, right? And what happens is these four screws that you see over here, right, these four screws, if I move the 2x1 out of the way, these four screws attach to our gearbox plate, and this is where there's a tapped hole so that the screws can thread into the aluminum plate. And there's also a tapped hole for these standoff holes because there's no lock nut over here. So we'll remember that all those holes needs to be tapped. And so what we can do is make four additional circles over here. And by the way, before we start that, let's make all of these non-construction. It should automatically keep them solid. I think I have a setting that makes them construction. So we'll do circle, and let's make four more. So we'll make one there. And at this point, we can go over here in surface bodies, hit plus, see this one, and right click and turn visibility off, because it gets a little bit annoying to have to see that thing the whole time. So we'll be left with like a normal sketch. And so what we can do is add two more circles. Let's make them all equal to each other, and equal, right? And so remember that all of these need to be tapped, and the screws we're using are quarter 20s. So if we head over to our chart, quarter 20 screws, and if we're going to tap them, the hole size is 0.201. So we'll come in here, we'll give these a dimension of 0.201, and let's move them somewhat in place. So there we have them. Now if you see, these holes are actually bigger than the 0.201, because remember, we just projected geometry from this first plate that we made, but these holes need to be smaller. So what we'll do is we'll actually make circles here, and we'll make these equal to our new holes that we just made, right? And because we don't need these outer holes anymore, we can make them construction. And let's do that for the other 4 holes here. So we'll do here, make it equal, and we'll make this we'll make it construction, not unconstruction. And circle here, circle there, make these 2 equal. Let's make these 2 construction. And if you hold down shift, you can select multiple items in a sketch like I just did here, and then hit equal between this one and that one. There we go. So they're all smaller now. Right, so how do we arrange these 4 holes over here? So you can do all sorts of patterns here, but generally what you want to try to do is have a common pattern, so that in case you need to swap things out, you're not trying to figure out what pattern you used. And so usually what I actually like to do is we can get rid of all these random holes here. We'll just have one, and what we can do is we can give it a dimension from the center, and this dimension here, what I generally like using is the dimension that Wexpro, the company, they also make parts for FRC, and they also have a hole pattern. And if you use that hole pattern, it's just more common things, and you don't have to remember all sorts of random numbers. So we can just do this 1.875 divided by 2, because 1.875 is the diameter of their hole pattern. And if you're confused about what this hole pattern is, I can show you. So we'll go on our parts library, we can go motion, let's do sprockets, and let's open up one of these, for example. So this is a sprocket, and you can see there's these 6 holes everywhere, right? And so if I measure these, so if I go tools, measure, if I measure any 2 opposite holes, they are 1.875 inches apart. So this is the pattern I'm talking about. And you could use any pattern you want really, but this way it just makes sure that you have something you can remember easily. So 1.875 divided by 2, because this is the radius, and we'll make it vertically constrained over here, right? And so you're thinking, wait, it's gonna collide with the other bearing hole, right? But we're actually not gonna use the top and bottom holes here. So what we'll do is we'll do a circular pattern, select that circle, and for the axis we'll select this point here, and you see it makes 6 automatically, so we'll just hit OK. And then we can select the top and the bottom one, and we'll make it construction. So we'll end up using only these 4 holes over here, right? So that's all we need on our plate. So what's the final step? Now we have to make the outside shape, right? And remember, with the first plate, what we did was we made circles around our screw holes, and we made these dimension 0.5. So we're gonna do the same exact thing here. So we'll make more circles around here, and around here, and around there. And we'll make all of these equal to each other. There we go, and equal. So those are our 1/2 inch standoff, like the standoff itself is 1/2 inch diameter. And the final thing left to do is connect some lines. So we'll go here, and we'll connect these 2 lines. I don't know why it's giving this thing here. And as you can see, if I were to connect a line between these 2, it wouldn't work because all these holes would be cut off. So what we can do here instead is we can just make a circle around these holes as well, and we'll make it the same dimension as this 0.5 over here. So anytime you're trying to make the outside shape and you run into the problem of accidentally cutting off holes or not having enough material around something, you can just add like a second circle, which will be the boundary, and it can define how much material you want. So we'll make these 2 lines tangent to the circles so that everything flows smoothly, right? So those are 2 lines there, and then we need a line in the middle here, And remember, we're not going to be using the sixth hole here, that's why it's construction, and that's why we don't care that the line's above it. So we'll make these two tangent here, and let's add a line over here on the top. And there we go. And now I could make these two lines there, but I'm just going to be lazy and mirror it. So we'll make a line there, and then we'll use mirror for these two lines. Here's the middle line, hit apply, and then now we can just make this middle line construction so it's not annoying. And there we go. We can finish sketch, extrude, and we'll make it symmetric and 1/4 of an inch again because we want this to be strong. And we want to select everything that's not supposed to be a hole. So this part, this part, this part, this part, and this big section over here, and these two sections over here as well. And there we go. There's our second plate. Alright, and so we can save this. Let's do Gearbox plate 2. And here's the part where it's really helpful, because if we go back to our original plate, right, plate number 1, if let's say I were to change, so remember this circle over here, the screw, is tangent to this circle here. So if I were to move the screw hole, right, so if we were to make it 2.3, you see it goes left, we finish the sketch, you see how those holes moved, and if I go on the second plate, you can see this orange lightning symbol lines up, which basically means that there's an update that's happened, and if you click on it, it'll update the part. So if you look, those two holes just went further left. And so this is the advantage of making derived parts. I can go in here and change these dimensions to whatever I want, and this part updates. If I go in here, this one will also automatically update, right? And then let's set our materials. So we'll go aluminum 6061, save the file, and we'll close that. We can close this one too. Right, so we're back to our assembly here, and you can see there's an update symbol because this file was edited. So we'll go place, and let's place our second file here, hit open, there it is, and now let's constrain it. So we want insert constraint on the bearing hole over here, and so now it can swing around, or should be able to swing around like that. And the next thing we can do is do a constraint, so we can use this hole here for the standoffs. And there we go. So there's our second plate, and this gearbox is done basically. We just need to make our hex shaft. So let's go on tools and let's measure this distance here. So we'll measure this in between the motors here. There's the bearing. So we need a hex shaft here that's 2.776 inches long. So what I will do is well, we can make a hex shaft. We can review making hex shafts again. So we'll go here, we'll go hexagon, and all of this should not be new at all because we've covered making hex shafts before. So 1/2 inch hex shaft, let's do a central hole of 0.201, and if you remember, this is dimension for a tapped 1/4-20, which means you can actually tap hex shafts. So we'll go here, dimension, and this was 13.75 millimeters or 0.541. So we'll finish the sketch, and we wanted this to be 2.776 inches long. So we'll make that 2.776, hit OK, and then we want this to be aluminum 6061, I think, and you can change the color of it to anodized black or anodized dark gray. I like the dark gray a little bit better, so we'll just use that. Control S, and we'll make it hex shaft 1. There we go. So now I will place this hex shaft here like that, and let's constrain it. So we'll do insert. You can select the circle of the hex shaft and the circle of the bearing, and right now it's going the opposite way, so we just hit post, or is that a post? No, that's aligned. Apply. and there's our hex shaft. Now, do you see a problem here with the hex shaft? It's in the right place, we have our spacers, we have our gears, but the problem here is the hex shaft can move in and out freely. Because this bearing is a hexagon, this hex shaft is an hexagon, and so in real life it can move in and out. There's nothing holding my hex shaft inside there. And the same thing over here. Well, over here we do have our motors that are kind of touching the hex shaft, so that would probably not be able to come out, but it can come out this way. And if the hex shaft comes out, all of my spacers and gears and everything would be loose in real life. So how do we make sure that this hex shaft does not come out? This is where I want to introduce a new concept of cluster shafts. So if you look in this gearbox here, if I pull out this hex shaft, if you look here, it's a hexagon in the middle, but the edges are actually round. And if you look at the bearing over here closely, it's not a hexagon bearing, it's a round bearing. And if you're wondering, well, what's the point of that? Well, if you look closely at the hex shaft, because the round portion is smaller than the hexagon profile, if you look closely, there are all these ridges, right? And the bearing is a 1/2 inch circle. So if my bearing is here around this round part, this hexagon bit can't go through my bearing because the hexagon is bigger than the circle inside my bearing, so it cannot go through. And we have the same thing on both sides. So if we have what's called a cluster shaft, and we have round bearings on each side, this hex shaft won't be able to move around, unlike this gearbox over here. So what we'll do is we'll open up our hex shaft, and we need to change the edges to be circular. Now we need to remove our bearings here as well. So we'll select these bearings, that one and that one. Again, if you hold shift, you can select multiple parts, right click and delete. Now that should make our hex shaft be able to move around because the constraint is no longer there, and our gear could probably move around. Yep, there it is. So now what we need to do is place round bearings here. So we'll go place, let's go back to our library, motion, bearings, 1/2 inch round, open that, place those two here, and then we can constrain them. And these constrain the same exact way as the hex bearing. So you pick the outside flange, and then you pick on the circle here on your plate and hit apply. Same thing on the other side. There we go, hit apply, and there's our two bearings. And so now we can constrain our gears back in place so that they're not freely floating in the air. And there we go. So our gears are back. The final thing we need is to make our hex shaft have those like round edges. So what we need to do for that is find out how tall this bearing is. So if we go on tools, measure, we'll measure this face of the bearing to its front, and it's 0.313, or if you make the measurement more precise, it's 0.3125. So that's how big of a round we need. And remember, we constrained our second plate to the bearing as well, so now it's also able to move around. So we need to constrain that as well. Let's constrain, insert, you can do a second standoff constraint, and that one, hit apply, and that's good to go. So let's hop on over to our hex shaft, and what we can do is we can just start a sketch at the edge of the hex shaft and create a circle. Now if you're wondering how this would be done in real life, this is where you would use a lathe and you would just cut away these edges of the hex shaft into a round portion. So for our round bit, we need to make the inside 0.5. Actually, this would be the outside. So you see those extra ridges here, and then we can make this outer dimension really anything. So we can make like 1 inch. Because what we're going to do is we're going to finish the sketch, we'll extrude, and we'll cut this part out. So if you see, if I'm on the cut mode, it will cut away anything that's there. And remember, this dimension here was 0.3125 inches, or 0.313. Right, so that's the portion we want. Hit OK. And then generally when you do this on the lathe, the black portion, it's like a little, almost like a paint layer on top, and it comes off. So I just like to simulate that in CAD and make this aluminum, flat again. So we can see what an actual cluster shaft would look like. And now you could do the same thing on the other side, but because we made this symmetrically, we can just mirror it over. So we'll do second extrusion, mirror it over our middle plane, hit OK, and there's our second cluster. But we do need to change the colors for it manually. So we'll go here, go back to aluminum, and there's our shaft with clusters on it. So we'll do Control S, close this, and now it's here. As you can see, it has the cluster on it. So we'll just do an insert constraint again there, and to the bearing, align this time, apply, and there we're good to go. Now we need a second hex shaft here, and so with the second hex shaft, remember this the hex shaft from here goes out to the wheels and everything. So this bearing can be in hexagon, but over here in the back portion, the hex shaft doesn't need to go anywhere else. So the hex shaft could slide out currently. So what we can do is we can make this one a round bearing as well. So we'll delete this hex bearing, and I'll just copy, Control C that round bearing and paste it here, and we can constrain it like so. Oh, that's the wrong one. We want the flange of the bearing to this plate over here, hit apply, and it should have taken away our gears, right? So it can move away now. So we'll do another insert on the spacer to the bearing, and that is fine now. Right, so we need to make a second hex shaft. So we'll go new part, and I'm just making a hex shaft here so you can, it's like a review, but I do have templates to make a hex shaft which work a lot faster. So we'll do 1/2 inch, and we'll do our central hole as 0.201. Alright, 201, and we'll do a second circle for the thunder hex part, the rounded edges, and we'll make this 13.75 millimeters. Finish the sketch, extrude it. So now this one, when you're making your gearbox, this doesn't have a specific length to it just yet, because the length of this hex shaft depends on how far your wheel is and where your wheel ends. So for now we can just say like 5 inches, and that works. And then we'll go in here, make a sketch, because we want one side to be, you know, rounded off, because we're gonna have a round bearing at the end. So we'll do 2 circles and dimension them. So we can make this like 1 inch, make this 1/2 inch, finish the sketch, extrude it, and we want to cut that portion to be 0.3125 inches, hit OK, and now we can set our material. So aluminum 6061, anodized dark gray, or you can do anodized black, doesn't matter, and aluminum for the round part, and we'll save this as hex shaft number 2. And so we'll come back here, and we're almost done with our gearbox actually. So we'll do place, let's go back to our workspace, hex shaft number 2, place that, and then we can constrain it. So let's go back to our hex shaft, there it is, and we will constrain it to our bearing over here, there it is, apply. And so now our hex shaft can't move inside. Right now it can move outside, but on the actual robot we'll have shaft colors and or like a screw and a stand washer at the end, so that the hex shaft can't move out the other direction. So that's it. That's how you make a gearbox. That's a complete gearbox. Now on our actual gearbox we do what's called lightning or pocketing. Basically you see all these gaps in the plate compared to this solid plate over here. These gaps are basically so that we save on some of the weight, because and the way they work is they still provide enough strength for this plate, so it's not like you just cut away a random portion, but they also save on some weight, and that's already covered in another video, but that's not necessary for making a gearbox. And so there it is, our complete gearbox and our first completed CAD challenge.